Okay, so for question number 6, we are going to predict the products for aqueous solutions of Epsom salt and barium chloride and write a balanced chemical equation. So we have our starting materials. We have barium chloride. Now, in order to generate a formula for barium chloride, we see that barium, we know, has a +2 charge. Chlorine has a -1 charge. So if we are to generate the formula, we can do a crisscross method where we crisscross our charges to become our new subscripts, and we see that we have Ba1Cl2, which you know then becomes BaCl2. And what you see is that the overall charge of this molecule is equal to 0. So you know you properly balanced it, And just to illustrate that, we see that we have one barium, and it has a +2 charge. We have 2 chlorines, and they both have a -1 charge. And what you see is that this is equal to 0. So you know you have the correct balanced chemical equation. So we have barium chloride, and the question itself told us that it has a aqueous phase. And in order to determine the chemical formula of the Epsom salts, you again have to look at the pre-lab reading, and what we see is that it is magnesium sulfate, and this is also in the aqueous phase as well. So the next thing that we have to do is we have to predict what our products are. So this, again, very similar to the previous questions that we did. We see that we have cations and we have anions, and so we want to swap them. Now again, it's going to be very helpful for you to go through and indicate what the charge is for the original compounds, for the cations and anions. So we know that barium has a +2 charge. We know that each of the chlorines have a -1 charge. So if we look at magnesium sulfate, we know sulfate is a polyatomic ion. It has a -2 charge. And in order for the overall compound to have a 0 charge, we know that magnesium has to be +2. So if we swap these, we take barium 2+ and compare it to sulfate 2-. So if we do another crisscross, we have Ba2SO4. And again, when we're balancing chemical formulas, we want to make sure that our subscripts are the lowest denomination. So we can divide both of these by 2, which become barium 1, sulfate 1, which you know is then written as BaSO4. So barium sulfate is one of our products. And if we look at our solubility rules in order to predict the phase of this compound, we see that generally sulfates are soluble unless they're paired with certain cations. Barium is one of those cations that, if paired with sulfate, actually fall out of solution as a precipitate in the solid phase. So we have one product done. Now we have to do the second product. And so we compare cation number 2, which is the magnesium with the 2+ charge, to anion number 1, which is the chlorine, which has a -1 charge. And again, notice that I'm not taking the subscript with the chlorine. That's because chlorine is not a polyatomic ion. So when that happens, you don't take the subscript with you. So we go through, we crisscross again, and we now have our new subscripts, Mg1Cl2, which then becomes MgCl2. So we have our second product, and if we look at our solubility rules, we see that magnesium chloride is aqueous in solution. So the last thing that we have to do is to make sure that everything is balanced by mass, and we see that all of the elements are balanced by mass, so we have our balanced chemical equation. We have our two products, the solid barium sulfate and the aqueous magnesium chloride. Now, in terms of predicting experimental observations, we know that we're going to see a precipitate of barium sulfate. So we will see this fall out of solution as a solid for this particular reaction.